Here we are on the fifth set, and in this video, we are going to solve it section by section. So let's move on to section A. So section A comprises of MCQs of 1 marks each, and the question number one says the number of polynomials having zeros minus 3, and this is the question number one. We have the zeros minus 3 and 5. Now we can get the zeros in n number of ways. So alpha can be minus 6 by 2, which is minus 3, or alpha can be minus 21 by 7, which is minus 3. So that means we can have the n number of ways to get minus 3 and also minus 5. So this the answer for this is infinite. So B is the correct option for the number of polynomials having zeros minus 3 and 5. These are the real numbers, and we can get them in infinite number of ways. Let's move on to question number two. Okay, for question number two, we have to find the value of we have to check which of this condition is true when the given pair of equations are parallel. So the given pair of equations are ax plus 2y is equal to 9 and 3x plus by is equal to 18. And we know that for the parallel lines, a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon b2. So let's put in the values of a1, which is a, a2, which is 3, b1, which is 2, and b2, which is b. So let's cross multiply this, which gives us ab is equal to 6. So ab is equal to 6 is the option D. So option D is the correct answer for this. For question number three, it's given that what is the common difference of the AP whose nth term is given by? So for question number three, the nth term of the AP is 3n plus 7. We have to find the common difference. So when we put n is equal to 1, we get first term. So this is 3n plus 7, which is 10. And when we put n is equal to 2, we get the second term, that is 3 into 2 plus 7, which is 13. And we know how to get difference, which is a2 minus a1, that is 13 minus 10 is equal to 3. So the common difference is 3, which is B. So the correct answer for question number 3 is B. For question number 4, in the given figure, it's given that D is parallel to DC. So this is the figure A, B, C, and D. So it's 2 centimeter, 3 centimeter, D is 4, and we have to find the value of X. Now this triangle ADE is similar to triangle ABC because by AA similarity rule, because A and A are the common angles and this angle is equal to this. These are the corresponding angles. So these triangles are similar. So that gives us AD by AB. So we can write AD by AB is equal to DE by BC. So this is DE by BC. Let's put in the respective values. AD is 2, AB. AB is 3 plus 2, which is 5. So this is 5. DE is 4 and BC is X. So if we cross multiply this is 2x is equal to 20, which is gives us x is equal to 10. So D is the correct answer for question number 4. For question number 5, we have to find the quadratic equation whose roots are. So alpha is 2 plus root 3 and beta is equal to 2 minus root 3. We have to find the quadratic equation, and we know that the quadratic equation is given by x square into sum of roots into x plus p. So sum of roots is alpha plus beta, so which is 2 plus root 3 plus 2 minus root 3, this gets cancelled, which is equal to 4. And the product of the roots is 2 plus root 3 into 2 minus root 3, which is a square minus b square, which is 4 minus 3 is equal to 1. And it was a square minus b square, 2 square is 4, root 3 square is 3, 1. So let's put in the respective values there. So x square minus sum of the roots is 4, x plus product of the roots is 1. So our given polynomial or the quadratic equation is x square minus 4x plus 1, which is option A. So option A is the correct answer for question number 5. Okay, for question number 6, it's given that tan theta is equal to pi by 2. So, sorry, tan theta is pi by 12. And if we consider theta to be the base angle in this right angle triangle, so theta is pi by 12. So tan theta is perpendicular by base, which is 5 by 12, and perpendicular is AB, and base is BC. So AB and BC are given, and we know how to get AC by using the Pythagoras theorem. This AC square is equal to AB square plus BC square. So AB square is 5 square, and BC is 12 square, which is 25 plus 144, which is 169 AC square. And we got this by using the Pythagoras theorem. So AC is equal to root of 169, which is 13. So this is 13. Now we have to evaluate for sine and cos. So sine theta is P by H, which is 5 by 13. And cos theta is base by hypotenuse, which is 12 by 13. And let's put in the respective values in this. This is sine theta plus cos theta or sine theta minus cos theta. So sine theta is 5 by 13 plus 12 by 13 upon 5 by 13 minus 12 by 13. So this is 17 by 13 divided by 5 minus 12 is negative 7 by 13. This gets cancelled, so this is negative 17 by 7. So negative 17 by 7, which is option A. For question number 7, we have to find the distance between the points PQ. And we know how to find the distance between the points PQ by using the distance formula. And P has the coordinates minus 11 by 3 comma 5, and Q has the coordinates minus 2 comma 3 comma 5. And this is, let's say, coordinates are x1 y1 and x2 y2. We know how to use the distance formula. So the distance between P and Q is PQ, which is x2 minus x1 the whole square plus y2 minus y1 the whole square. So x2 is minus 2 minus of minus 11 by 3 the whole square. Y2 is 5 minus 5 the whole square, which is 0. So this is minus 2 plus 11 by 3 the whole square plus 0. And this gives us minus 2 plus 11 is 9. So 9 by 3 the whole square in the root. So square root gets cancelled with square. This is 9 by 3, which is equal to 3 units. So 3 units is the distance between P and Q. So correct option here is option D. And for question number 8, it's given in the figure that AB is equal to BC is equal to 10 centimeter and AC is 7 centimeter. We have to find the length of B. So we are on question number 8, and let's try to get a rough sketch of this. So this is okay. So this is A, E and C, and these are the points of contact P, Q, and R. Now AC is given it's 7 centimeter, and AB and BC both are 10 centimeters. So this is 10 centimeter, and we have to find the length of BP. So BP has to be calculated, and okay, now uh, it's given that AC, so AC is equal to 7 centimeter. Now AC is the sum of AR plus RC, and AR is equal to AB because the tangents drawn from external point to circle are equal. So instead of AR, I can write AP, and instead of RC, I can write QC. So we have got this because AR is equal to AP and RC is equal to QC because tangents drawn from external point to circle are now AP. I can write AP can be written as AB minus BP. So AP is AB minus BP and QC. So QC is BC minus BQ. So this is BC minus BQ is equal to 7. Now AB is 10. BP and BQ are equal. So BP and BQ are equal. So BP is equal to BQ. Reason being 10 is drawn from reference point to circle are equal. So instead of BQ, I can write this. I can write BP and BC is 10 is equal to 7. So we are here now 10 plus 10 is 20 minus BP is minus 2BP plus 20 is equal to 7 minus 2BP is equal to 7 minus 20 is equal to minus 13. Negative gets cancelled. BP is equal to 35, 2, which is equal to 6.5 centimeters. So 6.5 centimeter, that is option C. So C is the correct answer for question number 8. Let's move on to question number 9. Okay, for question number 9, it's given that water in a river which is 3 meter deep and 40 meter wide. So this water in the river is flowing in the form of a wide shape. So let's say this is the river which has cuboidal opening, and the water is flowing and it's coming out of the river. So this river is 3 meter deep. So this is 3 meter deep and 40 meter wide. So first of all, the water gets filled in the mouth of the river and then it falls into the sea and at the rate of 2 km per hour. So how much water means volume of water. So volume of water flowing into sea in 2 minutes. So that will be the area of the cross section multiplied by the speed in 2 minutes. So it's given that this is 2 km per hour. So first of all, let's find out. So this is the volume of the water flowing into sea in 2 minutes that we have to find out. This is in 2 minutes. And for that, let's first of all calculate the area of cross section. So here, area of cross section of the river. So area of cross section of river is length into breadth, which is 40 into 3 is equal to 120 meters square. Now speed is equal to 2 km per hour, but we have the units in meters, so we will get this converted into meter per minute. So 2 km means 2 into 1000 meter. and r means has to be divided by 60. So this is meter per minute is the speed. And this is now 2 3 are 6, which is 100 by 3 meter per. So volume of water flowing into the sea in 1 minute is, so volume of water flowing into sea in 1 minute is equal to area of cross section is in meter square into the speed, which is now in meter per minute. So this is me. Now this is the volume of water flowing into the sea in 1 minute, which is 40 into 100, which is 4,000 meter cube. And in 2 minutes, it has to be multiplied by the 2, which is 4,000 into 2, which is equal to 8,000 meter cube. So 8,000 meter cube, that is the option C is the correct answer for this. For question number 10, we have to find the mode, and we know that the empirical relation between mean, median, and mode is, now the empirical relation between mean, median, and mode is, we all know that is the empirical relation between mean, median, and mode. So the relation between them is mode. We can write mode is equal to 3 median minus 2 mean. Let's put the respective the values in this relation, and we have to find the mode. So mode is equal to 3 into median. Median is 15 minus 2 into mean is 12. So this is 45 minus 24, which is equal to 21. So B is the correct option for the question number 10. And for question number 11, it's given that in the figure AB is a tangent to the circle centered at O. If OA is equal to 6, so we have given that OA is equal to 6 centimeter and angle OA is 30 degrees. We have to find the radius of the circle. So let's get connected the radius to the point of contact. So now we have to find the radius of the circle, which is A. Now in this case, we know that OB is perpendicular to AB. So OB is perpendicular to AB because radius is, so radius of this is now a right angle triangle, and right angle triangle OBA. So for 30 degree, this is the perpendicular, this is the hypotenuse, and this is base. We have to find OB, which is perpendicular. So P by H is sine. We are going to use the sine ratio. So sine 30 is equal to P by H, and we know that sine 30 is R. And okay, so P is OB, hypotenuse is 6, cross multiply this, which gives us OB is equal to 6 by 2, which is equal to 3 centimeters. So A is the correct option for question number 11. Okay, for question number 12, we have to evaluate it for the given angles of the trigonometry. So this is 2 tan 30 degree upon 1 plus tan square 30 degree. So this is tan 30 is 1 by root 3, and tan square 30 is 1 by root 3 the whole square. So this is now 2 by root 3 upon 1 plus 1 by 3. So this is 2 by root 3, and this is 4 by 3, which is equal to 2 by root 3 into 3 by 4. So this is 2 and 3 upon 2 root 3. If you rationalize this with the denominator, so this is 3 root 3 by 2 into 3, which is equal to root 3 by 2. Now, root 3 by 2, we don't have the numerical value, but we know that uh, sine 60 is root 3 by 2. So our option is sine 60, that is option A. For question number 12, before question number 13, it's given that in triangle ABC and triangle DEF, so for there is a set of corresponding sides that are in proportion, and in triangle ABC, let's say this is triangle DEF, this is triangle DEF. Now it's given that AB by DE is equal to BC by F. So AB by DE is equal to BC by FD. Now, to make these two triangles similar, we can use the SAS rule because we have the two sets of sides which are in proportion. So we are going to use the SAS rule to make sure that these two triangles are similar. And if we make them, the triangle ABC is similar to triangle DEF by SAS. To do this angle should be the included angle. So angle included angle is between these two sides, which is angle B, and between these two sides is angle D. So if it's angle B is equal to angle D, then these two triangles are congruent, similar by SAS similarity to. So it should be angle B is equal to angle D, which is the option B. Okay, for question number 14, we have to find the 11th term from the end. For question number 14, the 11th term from the end of the AP. So AP is 10, 7, 4 minus 62, and we have to find the 11th term, and most of you will use A 11 plus A plus 10D, but this is wrong because this will give you the 11th term from the beginning. We have to find it from the end. So in that case, what we are going to do, we are going to use the same formula of the nth term, but we are going to reverse the AP. So reverse the AP and it will still be an AP. So if we reverse the AP, this is minus 62 and then comes 4 and then comes 7 and then done. So now we have reversed the AP. Our first term is 62 and D is 7 minus 4 is equal to 3. And now when we use the formula of nth term, that is 11th term, this will give us the 11th term from here, which is the end. So A is negative 62, 10 into D is 3, which is negative 62 plus 30, which gives us negative 232. So negative 32 is the 11th term from the end, which is option C. So option C is the correct answer for this. Okay, for question number 15, it's given that the two coins are tossed together. We have to find the probability of at least one tail. So when two coins are tossed, our total outcomes are 2 square, which is 4, and the total outcomes are these are the total outcomes. 4, which is the sample space. Now we have to find the probability of getting at least one tail. So probability of getting at least one tail means it's the tail is greater than or equal to 1. So now greater than or equal to means either the probability of the tail is 1 or the probability of tail is 2. So now greater than equal to 1 means either the tail is 1. So these are the options in which the tail is 1, 1, and here the tail is 2. So we have to consider all these three options. So which is 3, and the total outcomes were 4. So the required probability is 3 by 4, which is option C. And let's move on to question number 16. Okay, for question number 16, uh, okay, it's given that AC and AB are tangents to a circle. So these are the tangents to a circle. And it's given that angle COD is 120 degree. We have to find angle BAO. So let's redraw this figure. This is the circle. This is the tangent AB. So this is AB, and this is the tangent AC. This is O, and this is C, and this is the line passing through the center, which is joining the diameter as well. And this is the angle that we have to find out. And it's given that angle COD is 120 degree. So angle COD is equal to 120 degree, which will give us angle AOC. So AOC is 180 degree minus 20, because these two angles make the linear pair, which equal to, so this angle is 60 degree now. This one is 90 degree. So OC is perpendicular to AC, because radius is perpendicular to the tangent at the point of contact. And now if we use the angle sum property in triangle AOC, so in triangle AOC, in triangle AOC, angle OAC plus angle AOC plus angle ACO is equal to 180 degree, and this is because of the angle property of triangle. Now angle OAC is unknown, AOC is 60 plus 90 degree, which give us angle AOC is equal to 180 minus 150, which is equal to 30 degree. So this angle is 30 degree, and this angle is also 30 degree, because the line joining the center to the common point, to the external point of the two tangents from where they are drawn, makes equal angles with the tangents. So this angle is also this angle is also 30 degrees. So angle OAB is equal to angle OAC, which is equal to 30 degrees. So this is option A is the correct answer for question number 16. Let's move on to question number 17. For question number 17, uh, it's asked which of the following numbers cannot be the probability of happening of an event. Now we know that the probability of the event can be 0 or can be 1. 0 is impossible and 1 is a sure event, or it's between 0 and 1. Now the first one is 0, which is possible. Now the second one, this is 7.0.01, which is equal to 700. Now the possibility should lie between 1 and 100. This is greater than 1. So this is not the probability of an event, and it's asked what cannot. So this cannot be the probability of happening of an event. So our answer for this is option B. Okay, for question number 18, it's given that every term of the statistical data consisting of n terms is decreased by 2, then the mean of the data, what would be the new mean? And we know that The mean is given by the formula summation of sigma fi into xi by sigma fi. Now this, all the terms, that is the new term is decreased by 2. So what would be the new mean? So let's put in the value. So that is sigma fi, and xi is now xi minus 2 upon sigma fi. If we expand this, this is equal to sigma phi into xi minus sigma phi into 2 upon sigma fi. So which is equal to sigma fi into xi upon sigma fi minus sigma fi upon 2 into sigma upon sigma fi, which gets cancelled. And this was our mean. So this is mean, and we are left with 2. So the new mean is so the new mean is equal to the original mean minus 2. So that means the mean also decreases by 2. So it also decreases by 2. So option A is the correct answer for question number 18. Let's move on to question number 19. For question number 19, that is assertion and the reasoning based question. And it's given that the points A and B lie on a circle with center O. So let's say this is the circle with center O, and this is the point A. I have joined the point A has coordinates 4, 3, and O. Center O has coordinates 2, comma 3, and there is a point B that lies on the circle has coordinates x, comma 5. Let's join them. So now OA is equal to OB. This is because of the radii of same circle. Now OA, we can find out OA using the distance formula, which is 2 minus 4 the whole square plus 3 minus 3 the whole square under root, and OB is x minus 2 the whole square plus 5 minus 3 the whole square. Now 3 minus 3 is 0, and square root and square root gets cancelled. 2 minus 4 is minus 2 square, and this is a minus b the whole square, which is a square plus b square minus 2ab plus 2 square. So minus 2 square and 2 square is equal to 4. So finally we have x square minus 4x plus 4 is equal to 0, and this can be factorized. So it is 2x minus 2x plus 4 is equal to 0. So this is x into x minus 2 into minus 2 into x minus 2 is equal to 0. So x minus 2 into x minus 2 is equal to 0, which gives us x is equal to 2 and x is equal to 2. So these are two equal roots. Now it says the value of x is 2, which is true. So the assertion is true. Now center of a circle is the midpoint of each chord. So it's not of for each chord, but it's only for the chord that is a diameter. So only the diameter will have the center as the midpoint. It's not each chord. So for this, it's false. So only the diameter will have the center of the circle as a midpoint. So in this case, assertion is true, but reason R is false. So our answer for question number 9 is option C. And let's move on to question number 20. For question number 20, the number 5 raised power n cannot end with digit 0, where n is a natural number and the prime factorization of 5 has only two factors, 1 and 5. Okay, that is the reason. So let's first check the assertion. Okay, number 5 raised power n, where cannot end with digit 0, where n is a natural number. So if we take n is equal to 1, then 5 raised power n is 5, and this does not end with digit 0. N is equal to 2, it's 5 square, which is 25. N is equal to 3, which is 5 cube, and it's 125 now. To a number with n with 0, let's say it's 10. Now it should have prime factors 2 and 5. But 5 has no prime factors. So it has only two prime factors, 1 and 5. It doesn't have any prime factor 2. So that means the 5 raised power n cannot end with digit 0. And to end with digit 0, it should have a prime factor 2 as well. So that means this assertion it's to 5 raised power n cannot end with digit 0. Now, prime factorization of 5 has only two factors, 1 and 5. That is not the reason. Reason is that it does not have 2 as a prime factor. For any number to end with 0, it should have 2 as a prime factor as well. So in this case, assertion is true and reason R is false. So option C is the correct answer for question number 20. Before we are on section B, and for question number 21, we are going to solve both the parts A and B. And it's question number 21, section A, sorry, part A. Now the line segment joining the points A and B is divided by the points such that AP is to AB is equal to 2 is to B. We have to find the coordinates of P. So it's given that there is a line which joins the points A is 4 comma minus 5 and B is 4 comma 5. So there is a line joining them and there is a point P such that AP is to AB. So it's given that AB is to AB is equal to 2 is to 5. So that means AP is equal to 2x and AB is equal to 5x. So this is AB, which is 5x, and AP is 2x, so which gives us PB as 3x. So PB is equal to AB minus AP, which is 5x minus 2x, which is 3x. Now, to find the coordinates of the point P, we have to get the ratio in which AB divides uh, A, in which P divides AB. So this is AB is to PB, which is equal to 2x by 3x, and the ratio is 2 is to 3. And now we are going to use the section formula to find the coordinates of P. So let's write down the section formula. And using section formula, we are going to get the coordinates of P. And the section formula says that the coordinates of P x comma y is equal to m1 into x2 plus m2 into x1 upon m1 plus m2 comma m1 into y2 plus m2 into y1 upon m1 plus m2. Now x comma y, so it's x comma y, which is equal to m1. So this is m1 and m2. M1 is 2 and x2 is 4 plus m2 is 3 and x1 is 4. So m1 plus m2 it's 2 plus 3, which is 5, and now m1 is 2, y2 is 5, m2 is 3, and y1 is negative 5 upon 2 plus 3, which gives us x comma y is equal to 2 into 4 is 8 plus 12 by 5, and this is 10 minus 15 by 5. So this gives us x is equal to 8 plus 12 is 20 by 5, 10 minus it's negative 5 by 5, which gives us the coordinates. So these are the coordinates x comma y. And finally, our coordinates x comma y are 5, 4 are 20 and 4 comma minus 1. So these are the coordinates of the point P, which are 4 comma minus 1 are the coordinates of the point P. Let's move on to the part B, which says that point P is equidistant from points A and B. So there is, let's say this is point P, which is equidistant from point A, 5 comma 1. This is part B, and this is B1 comma 5. And the distance from A of P is PA and PB. So it's given that PA is equal to PB. Now PA is x minus 5, this is x, minus 5 the whole square plus y minus 1 the whole square, that is the distance PA, and PB is x minus 1 the whole square plus y minus 5 the whole square, and then now root and root gets cancelled. Let's open this. This is a square plus b square minus 2ab plus a square plus b square minus 2ab. This is a square plus b square minus 2ab plus this is a square plus b square minus 2ab. Now, these terms can be cancelled out, and we are left with, let's write down what we are left with. And we are left with 25 plus 1 is 26. So 1 and 1 and 25 and 25 also gets cancelled. So this is minus 10x. And finally, we have minus 10x plus 12x is equal to minus 10y plus 2y. Minus 10x plus 2x is minus 8x is equal to minus 8y. 8 and 8 gets cancelled. So x is equal to y. That's what was asked to prove. And this is also question number 21. Let's move on to question number 22. For question number 22, it's given that in the given figure, we are on question number 22, and it's given that PT is a tangent to the circle. So let's draw a circle. This is the circle, and PT is a tangent that's drawn to the circle. So this is PT, and P also joins the center O. AB is a chord. And OC, this is OC, this is OA. And it's given that OC is perpendicular to chord AB. So it's given that OC is perpendicular to chord AB. And we know that perpendicular from the center bisects the chord, so BC is equal to AC. And then let's write down what we have to prove. So we have to prove it's PA into PB is equal to BC square minus AC square. And so let's get started. And first of all, this BC is equal to AC because perpendicular from the center, perpendicular from the center, it bisects the chord. Now perpendicular from the center bisects the chord, and let's consider the left hand side. So left hand side is PA into PB. So PA. Now PA can be written as BC minus AC. So this is BC minus AC, and PB. So PB can be written as BC plus BC. So this is BC plus BC. Now we have to prove AC. Now we can replace BC with AC because BC and AC are equal. So it's BC minus AC into BC plus AC, and this is from 1. So this is now equal to A minus B into A plus B, which is A square minus B squared. So BA into BB is equal to BC square minus AC square, and that's what was asked to prove. And let's move on to question number 23. Okay, for question number 23, we're using the prime factorization. We have to find the HCF and LCM of 96 and 120. So let's prime factorize 96. So this is 2, 4, 8, and 24, and 12, 2, 6, 2, 3. Now 120 is 2 into 60 to 30 to 15 and 3 into 5. So that means 96 is equal to 1. This is 2 raised power 5 into 3 into 3 and 120 is equal to 2 cube into 3 into 5. Okay, we have to find the HCF and LCM, so let's find out HCF. So for the common factors, HCF is among these two, we have to take the smallest one, 2 cube, and among these it's 3. So it's 8 into 3, which is equal to 24. Now let's find the LCM. So among the common, we have to take the highest 2 raised power 5 into 3 into 5. Now 2 raised power 5 is 32 into 15, which is equal to, so let's multiply 32 into 15, 5 to 10, 15, 16 into 32, which is equal to 480. So this will 480. So HCF is equal to 24 and LCM is equal to 480. And let's move on to next question, question number 25. Okay, for question number 24, we have to find the ratio in which the y-axis divides the line segment joining the points 5, comma minus 6 and minus 1, comma 4. So let's say our points are A, which is 5, comma minus 6, and B, which is minus 1, minus 4. And this is being divided by the y-axis. So the coordinates on y-axis are 0, comma y, and we have to find the ratio so that the required ratio be k is to 1. So let the required ratio be k is to 1, and let coordinates of point P on y-axis be 0, comma y. Now let's use the section formula. So using section formula, we are going to get the required ratio. So section formula says that it x comma y is equal to m1 into x2 plus m2 into x1 upon m1 plus m2. This is m2, sorry, this is m1 into y2 plus m2 into y1 upon m1 plus m2. Now x comma y, the coordinates of the point are 0, comma y. So x is 0, it's being on the y-axis, and m1 is xk. Now x2 is negative 1 plus m2 is 1, and x1 is 5 upon k plus 1, and m1 is k, y2 is negative 4 plus m2 is 1, and y1 is negative 6 upon k plus 1. Okay, now let's equate this. So 0 is equal to negative k plus 5 upon k plus 1. And if we cross multiply this, this gives us negative k plus 5 is equal to 0. So negative k is equal to negative 5. And k is equal to 5 is to 1. So the required ratio is 5 is to 1. And this solves on question number 24. Let's move on to question number 25. For question number 25, it's given that a plus cos theta plus b sin theta is equal to 1. So we are on question number 25a, and it's given that a cos theta plus b sin theta is equal to m, and the next equation is a sin theta minus b cos theta is equal to 1. So let's say this is equation 1, this is equation 2. And we have to prove that a square plus b square is equal to m square plus n square. So we are going to square and add 1 and 2. We get. So square and adding 1 and 2 we get. So let's square this. So this is a cos theta plus b sine theta the whole square plus square and add. So this is a sine theta minus b cos theta the whole square, which is equal to m square plus n square. Now this is a plus b the whole square, which gives a square plus b square plus 2ab sine theta into cos theta plus this is now a square plus b square minus 2ab sine theta into cos theta, which is equal to m square plus n square. Now this gets cancelled, and this is a square. For this, the a square is common, so we have cos square theta plus sine square theta, and b square sine theta plus b square cos square theta. This is b square sine square theta plus cos square theta, which is equal to m square plus n square. Now sine square theta plus cos square theta is 1. This is 1. And finally, we get a square plus b square is equal to m square plus n square. Okay, this is the part A that we have proved. Let's move on to part B, for which we have to prove that the trigonometric identity. So let me erase this. And okay, for question number 25, part B, we have to prove the trigonometric identity, and let's consider its RHS. So question number 25, part B, let's consider its left hand side, which is secant A minus 1 upon secant A plus 1 under root plus this is secant A plus 1 upon secant A minus 1. So secant A is 1 by cos A minus 1 upon 1 by cos A plus 1 the root plus this is 1 by cos A plus 1 upon 1 by cos A minus 1. Okay, let's take LCM. So this is 1 minus cos A, and this is 1 plus cos A. So denominator being same gets cancelled, so this is under root, and this is also 1 plus cos A on cos A, 1 minus cos A on cos A, this gets cancelled, and now this is equal to under root 1 minus cos A upon 1 plus cos A. This is also 1 plus cos A upon 1 minus cos A. Let's rationalize both these in the square root. So rationalizing this gives 1 minus cos A upon 1 plus cos A into 1 minus cos A upon 1 minus cos A under root plus this under root 1 plus cos A upon 1 minus cos A into 1 plus cos A upon 1 plus cos A. Now this is 2 times, so we can write it as 1 minus cos A the whole square in the root, and this is A plus B into A minus B is A square minus B square plus this is 1 plus cos A the whole square upon this is A square minus b squared. Now we know that root of a upon b is equal to under root a upon under root b. So this is root 1 minus cos a in the whole square. So this gets cancelled. And it says 1 minus cos square is the square is. So this gets cancelled with the square root. This is 1 plus cos a whole square. The square gets cancelled with square root. This is 1 minus cos square a, which is sine square a. So this gets cancelled. Now, what we have left is this is 1 minus cos a on sine a plus. This is 1 plus cos a by sine A. And taking LCM once again. So if we take LCM once again for this, it gives. So let's take LCM for this, which gives this is equal to sine A. This is 1 minus cos A plus 1 plus cos A. Cos A gets cancelled. So this is 2 upon sine A, which is equal to 2 into 1 by sine A. And this is equal to 2 into secant A, that is equal to R. Okay, so this solves our question number 25. Let's move on to section C for question number 26. Okay, for question number 26, section C, we have to prove that root 3 is an irrational number. So it's question number 26, part A. We have to prove that root 3 is an irrational number. So let's assume that root 3 is uh, a rational number. So if root 3 is a rational number, that means root 3 is equal to a by b, where a and b are co-primes. Now, if a and b are co-primes, that means they have no other vector except one, common factor except one, like 2 and 3. So 2 and 3 are co-primes. So let's cross multiply this, which gives a is equal to b into root 3 and square on both sides. We get this is a square and this is 3b square. So a square is equal to 3b square means a square is dividend, 3 is quotient, so 3 is divisor, b square is quotient, and remainder is 0. So this gives us dividend is equal to divisor into quotient plus remainder, which gives us a square is equal to 3b square, where 3 divides a square. So this gives that 3 divides a square. So if 3 divides a square means 3 divides a. Okay, if 3 divides a, so that means there has to be some integer that divides a. So let that integer be c. And now a is equal to 3c according to division algorithm. So let's say this is 1, this is equation 1. And if we put 2 in 1, we get, so this is now 3c the whole square, which is equal to 3b square. This is 9c square is equal to 3b square. So 3 3s is 9, which gives 3c square is equal to b square. So this means 3 divides b square. So if 3 divides b square means 3 divides b. So if 3 divides means, so 3 divides b and 3 divides a, but a and b were co-primes, so that means this contradicts our assumption. This contradicts our assumption, and hence a and b are not co-primes, and if A and B are not co-primes, so if A and B are not co-primes, that means root 3 is not a rational number, but is an irrational number. So root 3 is an irrational number. Okay, now let's move on to its OR part for B, where the traffic lights at three different row crossings change after every 48, 72, and 108 seconds. If they change simultaneously at 7, at what time will they change together next? So we will have to give the time. And now these lights changes at 48, 72, and 108 seconds. So let's get their LCM first. So this is 24 to 12 to 6 and to 3. So 48 is equal to 2 raised power 4 into 3. And 72, if we divide it by 2, this is 36 to 18 to 9 and 3, 3. So 72 is equal to 2 cubed into 3 square. And 108 is 254 to 27, and 3 nines are 27, and 3 threes are 9. So 108 is equal to, this is 2 square into 3 cube. Now LCM here is, for these it's 2 raised power 4, and for these it's 3 cubes. So 2 raised power 4 is 16 into 27. Now 16 into 27 is 7, 6, 42, 6 to 12, and 4 is 16, and 27 to 13 to 3, 4, which is 432 seconds. And if we convert them to minutes, so this is 432 divided by 60, which will give us the minutes. And 432 divided by 60, 6 sevens are is 420. So this is 7 minutes 12 seconds. So that is, if the light changes at 7, then they will change again at 7 past 7 minutes and 12 seconds. So this is, lights will change together again at 7 past 7 and 12 seconds. So this is the time when the lights will change together next. So 7, 7, 12. And that's also question number 26. Let's move on to question number 27. For question number 27, it's given that the pth term of an AP is Q and qth term is P, then prove that nth term is P plus Q minus N. Okay, now this is question number 27, and the pth term, so pth term is equal to Q, and we know that pth term is given by, if nth term is, we know that nth term is given by a plus n minus 1 into d. So nth term is a minus 1 into d, then pth term is ap, which is a plus p minus 1 into d. So here I can write a plus p minus 1 into d is equal to q, which is 1. Similarly, it's given that qth term, so it's given that qth term is equal to p, so qth term is a plus q minus 1 into d, which is equal to p. This is equation 2. Now, if we subtract these two equations, we will get the value of d. So this is a plus p minus 1 into d is equal to q, and this is a plus q minus 1 into d is equal to p. So this is negative, negative, and negative. So this gets cancelled, and it's d. So this is p minus 1 minus q minus 1 is equal to q minus p. So if I open up the bracket, this is p minus 1 minus q plus 1 is equal to q minus p. So 1 and 1 gets cancelled. This is d into p minus q. And if I take negative common, so this is p minus q. So d is equal to negative of p minus q upon p minus q. So this is negative 1. So if d is negative 1, from 1 we can get the value of a. So is we can write from 1, this is a plus p minus 1 into minus 1, which is equal to q. So this is a, and minus p plus 1 is equal to q. So a is equal to p plus q minus 1. And now we have to find the nth term. So nth term is a plus n minus 1 into d, and a is p plus q minus 1 plus n minus 1. D is negative 1, so which gives me p plus q minus 1 plus n. This is negative n plus 1, 1 and it's cancelled. So finally, n term is p plus q minus n. This is what was asked to prove. So nth term is p plus q minus n. Let's move on to question number 28. Okay, for question number 28, part A, in the given figure, it's given that the perpendicular bisector of CD is the perpendicular bisector of AB. So let's write down the given information. It's question number 28, part A. And so it's given. Okay, now CD is the perpendicular bisector of AB. So CD is the perpendicular bisector of AB. So that means AD is equal to DB. Now EF is perpendicular to CD as, so EF is perpendicular to CD, and it's given that EF is perpendicular to CD and AD is equal to DB, which is a perpendicular bisector also. CD is perpendicular to AB. Now we have to prove it's CF by CD is equal to FG by DG. Now let's see where we can find the sides. So CF is in triangle CEF and CD is in triangle BCD. So we are going to prove these two triangles similar. And let's see what happens. So this is in triangle CEF, and the bigger one, that is BCD. So this is the figure. And here angle C is equal to angle C, which is common. And angle F, that is EFC, is equal to angle BDC, both being each 90 degree. So therefore, by a similarity rule, triangle CEF. Let's write the symbolic form correctly. So C was equal to C, so this is C, and F was equal to D, so corresponding to F, it's D, and we'll put B in here. Now let's write down the sides that are in proportion. So it's CF by CD. So this is CF by CD is equal to EF by CB. This is EF by CB and C by CB. So this is CB by CB. Let's keep it as it is, and we got this result because the corresponding sides of similar triangles are in proportion. Okay, now let's move on to the next set of triangles that we have to prove similar. Now it's CF by CD FG. FG is in triangle EFG, so we are going to prove these two triangles similar in triangle EFG and DG. DG is in triangle DGA, so this is triangle DGA. So for these two triangles, so angle F is equal to angle D, each being 90 degree, and angle EGF is equal to angle AGD. These are vertically opposite angles. So therefore, by a similarity rule, triangle EFG, let's write them in the symbolic form. So EFG and F is equal to D. So F and D, and the vertically opposite angles are G and D. So G and G, and for DGA we are left with A. And once these triangles are similar, let's write the sides in proportion. So this will be EF by AD. So EF by AD is equal to EG by AG. And so this is EF by AD and EG by AG and FG by 8. Let's see what is. So we will keep CFCD. So this is CFCD and FG and 8. FG and DG. So this is FG and DG. Sorry. So this is FG and DG. Now from this, we need to keep CF by CD and FG by DG. And the common here is we will just remove this. We don't need this. So this is, and also CD by CB. Okay, now here, this, let's say this is our equation 1. And it's given that AD, so AD is equal to DB. So instead of AD, I can put DB. So this is EF, and here it's EF by BD. So this is EF by BD. So EF by BD, and this is EF upon, instead of AD, I can write BD, which is equal to FG by DG. Now, instead of AD, we have written AD because AD is equal to BD, it's given. Now this is equation 2. So from 1 and 2, we get this is CF by CD is equal to FG by DG. So it's CF by CD is equal to FD by DG. And now let's move on to the part B of the same question. For this, we are going to raise all this. So in the given figure, it's given that ABCD is a parallelogram. So ABCD is a parallelogram. So this is ABCD. This is ABC and BE bisects CD. BE, this bisects CD. So this is BE that bisects CD, and M, and AC intersects this EB. So this is E, and AC, it intersects. Okay, now what is given to us is that ABCD is a parallelogram. So ABCD is a parallelogram and BE bisects CD and M. So BE it bisects CD and M. So B bisects CD and M. So that means DM is equal to MC. So that is DM is equal to MC. Now AD intersects CD at G. So we have to prove that CF. So prove okay, B is we have to prove that EL is equal to 2 times BF. Okay, now let's consider these triangles we are going to prove. And let's consider these triangles. So in triangle, this is the first one is triangle ELA. So the triangle ALE and CLB. So this is ALE and CLB. So in triangle ALE and triangle CLB. So in these two triangles, ALB and CLB, angle L is equal to angle L. These are the vertically opposite angles. Now this is a transversal for the side A and BC. So angle E is equal to, I can write angle AEL is equal to angle LBC. And these are alternate interior angles are equal. So therefore, by a similarity rule, we can say that triangle ALE is similar to triangle CLB. So triangle ALE is similar to triangle CLB, and if they are similar, so that means AL by CL is equal to EL by LB. EL by LB or EL by, we can say BL. So let's say this is our first set of the proportion sides, and this we got the result because the corresponding sides of similar triangles are in proportion. Okay, now let's take these triangles. So the next set of triangles which we are going to prove similar are triangle CLM. This is CLM and triangle ALB. So CLM and triangle ALB. So here also angle L is equal to angle L. These are the vertically opposite angles. So these are the vertically opposite angles. And angle C is equal to, we can say that angle MCN is equal to angle LAB. These are the alternate interior angles. So we can say that by a similarity rule, triangle C and M is similar to LB. Now, if triangle CLM is triangle to is CLM is triangle ALB, so that means we can write this is CL by AL or CL by AL is equal to this is CL by AL is equal to CM by AB. So CM by AB. And let's try to reverse them. So this is AL by CL, or cross multiplying this will give us AL by CL is equal to AB by CL. Okay, now if we compare the equation 1 and equation 2, so from 1 and 2, this is AL by CL. So 1 and 2 we get This is EL by BL is equal to AB by CM. So now uh, this AB is equal to CD because these are, so AB is equal to CD because these are the opposite sides of the parallelogram. For this, I can write EL upon BL, and instead of AB, I can write CD upon CM. So because this is because AB is equal to CD, these are the opposite sides of a parallelogram are equal. Opposite sides of a parallelogram, and now CD is being bisected at M, so that means CD is 2 times MC. So CD is, so B bisects CD at M, dm is equal to MC. This gives CD is equal to 2 times CM. So instead of CD, I can write 2 times CM. The CM gets cancelled. So EL is equal to 2 times BL. And this what was asked to prove EL is equal to 2 times BL. And this also the question number 28. Let's move on to question number 29. Okay, we are on question number 29. And for question number 29, uh, this is question number 29, and it's been asked to find the speed of the two persons on the road. Now they are walking, they are 16 kilometer apart on a straight road. So let's say this is the straight road, and let this be person A and this be person B. Now when they start walking they at the same time, if they walk towards each other, so that means they are walking towards each other in opposite directions. So they are walking towards each other and they will meet in 2 hours. So they meet after 2 hours. So time taken by B is 2 hours and time taken by A is 2 hours, and they meet, let's say, somewhat here. So let's say they meet after 2 hours. Now let X speed of person A, let's say speed of person A be X kilometer per hour. And it's given that they are moving with different speeds, so that means someone is walking faster than the other. So let's say X is the greater speed and speed of person at point B be Y kilometer per hour. And in this case, we are considering that X is greater than Y. Now, when they walk towards each other, so when they walk towards each other, so they meet after 2 hours. So if X kilometer per hour is the speed of A and Y kilometer per hour is the speed of person at point B. Now the distance traveled by person at point A is, the formula is distance equal to speed into time. So for this person, speed is X and time is 2 hours. So he travels the distance 2x. And similarly in this case, the speed is Y and time is 2 hours. So distance traveled by the person at point B, dB and dA. So this is 2y and 2x. So they meet at this point and the total distance traveled by them. So if we add this and this distance, it's 16 kilometer. So we can say that 2x plus 2y is equal to 16 kilometer, and which gives us x plus y is equal to 8. And let's say this is our first set of equation now. when they walked in the same direction with same speeds. So let's say, let me just draw this figure once again. And this time they are walking in the same direction. So this is person at point A and this person at point B. And now they are walking in the same direction, let's say towards the left. Say both of them are walking towards the left and they meet after 8 hours. So both of them meet after 8 hours. The speed of A is more than the speed of B. So distance traveled by A is equal to 8, that is speed into time. Its speed is x. So distance traveled by A is x into time taken, that is 8x. Similarly, the distance traveled by B would be in, yeah. No. Okay. So now when they both of them walk in the same direction, so let's say T walks this distance, this is 8y, and E walks this distance, is 3x, and both of them. So the difference of the distance between x, this is with x distance, and then the distance traveled by b difference. So the y, so 8x minus 8y will be the 16 kilometers. And if we do create the problem, this is x minus y is equal to 2. So our second set of equation. So let's now resolve these two set of equations. The first set involves x plus y is equal to 8, and the second involves x minus y is equal to 2. So this is x minus y is equal to 3. And the option which makes us makes is equal to 10, x is equal to. Similarly, we subtract them, x plus y is equal to 8, x minus y is equal to 2. If subtract them, this gives us 2y is equal to 6, this gives us y is equal to. So the respective find and walking speeds, so their walking speeds are 5 and 2 kilometers per hour. So we are in 5. This solves our question number 29. Let's try to solve the question number 30. Number 30, that the relative identity. So let's consider the left hand side. Consider left hand side which is 10 theta that minus cos theta plus theta for round minus 10. But we will try to get this convert to write all of this in terms of sine and cos. Is 10 is sine theta by cos theta for cos is 1 minus cos by sine cos theta. by sine cos cos by sine tan is 1 minus sine. So sine by cos is so sine is which is actually cos theta. But it's still so this will be sine squared theta for cos theta. So to sine theta minus cos theta. And if you take negative out, so this is plus minus is minus, and this is cos squared. So we have taken negative out from this term, then this will be sine theta minus cos. Now we can integrate LCM for these two. LCM is this is sine theta into cos theta, sine theta minus cos theta, which gives us this is now sine theta minus cos theta. If this is now O2 minus V2, and we know the minus BC is A minus B square plus 3B plus B square. So you have to use for the pair. So this is now over speed is minus B. Get it sine square theta plus cos square theta 1. We are left with 1 plus sine theta cos theta. So this is 1 plus sine theta cos theta on sine theta because which is now 1 for sine theta to cos theta plus sine theta into cos theta for sine theta into cos theta. So this gets calculated as 1. And 1 upon sine is cosecant. So this is 1 by sine to cosecant theta into and 1 by 4 is secant theta plus 1. So we can write it as 1 plus secant theta both thinking about there was both thinking about. The answer is true. That was we are going to trigonometry diagonally for additional method 2. Let's move on to the next question. For question number 31, we are to find the mean of the following frequency distribution. And let's write down the given information in the tabular format. So the class intervals are given as 25 to 30, 30 to 35, 35 to 40, 40 to 45, 45 to 50, yeah, 50 to 55, 55 to 60. And the frequency Fi is given as 14, 22, 16, 6, 5, 3, and 4. Let's find out the class marks as we are going to use the step division method for this. So the class marks are divided by xi. So 25 plus 30, that is the upper plus lower limit, is 55 divided by 2 is 22.5. Okay, it's 55 divided by 2 is 27.5. So this is 27.5. The class marks. We know how to find the class marks. And upper and the lower limit, which is 55, and then divide it by 2, which is 27.5, and we are going to do for every class interval. So this is 27.5. Now this is 32.5 and 37.5. The difference is 5, so keep on adding 5. So this is 42.5 and then 47.5, 52.5 and 57.5. Okay, so we have got the class marks and let's find out the deviation which is equal to xi minus a, where a is the assumed mean, and for us the assumed mean is 42.5, which is in the center of the class marks. So this is a is 42.5 and okay, so 27 minus 42.5 is negative. Okay, we have to subtract 42.5 from 27.5, which gives us this is 12 minus 7 is 5 and 15. This is negative 15 and 32 minus 5. Subtract 42.5 from the 2 minus 5, which is 10. So this is negative 10, which will be negative 5, 0, and then 5, 10, and 15. Okay, now and let's find out the next column, that is UI, which is, so we are going to find out the next column is UI, which is DI divided by H, and H is the class size, which is upper limit minus lower limit, which is 5. So divide each of these DI with 5. So this is negative 3, negative 2, negative 1, 0, 1, 2, and now we are going to multiply F5 with UI. So 14 into 3. So this is F5 into UI. So 14 into 3 is negative 42. 22 into minus 2 is negative 44. 16 into minus 1 is negative 16. This is 0. 5 into 1 is 5. 3 2s are 6. And 4 3s are finally 12. So if we add these negative terms, it will give us, this is 42, 44, and 16, 6, 4, 10, and 12, 4, 4, 8, 9, and 10. So this is negative 102, and we add them. This is 5 plus 6 is 11, which will give us 23. And let's add these. So this will give us the summation of this column sigma fi into ui. So this is negative 12 minus 3 is 9, and this is 9 minus 2 is 7, so this is negative 79. And let's get the summation of the frequency as well. So it's uh, If we add them, so 4 plus 2 is 6, 6 plus 6 is 12, 6 is 18, 5 is 23, and 3 is 26, and 4 is 30. This is 3 plus 1, 4, 5, 6, 7. This is 70. So sigma Fi is 70, and now we are going to find the mean, which should be A plus sigma Fi into Ui by sigma Fi into H. So A is assuming which is 42.5 plus sigma Fi Ui into Ui is negative 79 divided by 70 into 5. So this gets cancelled. It's 5 over 5 and 5 over 20. So this gives us 42.5 plus or minus is minus and 79 divided by 40. So if we divide 79 with 40, so 79 divided by 40 will give us 5.64. So this is equal to 42.5 minus 5.64. And finally, our mean is 42.5 minus 5.64, which will give us 6. 14 minus 6 is 8, and 11 minus 5 is 6. So this is 36. 5, 8, 6 is the mean. Okay. So this solves our question number 31. Let's move on to section B of 5 marks each questions and try to solve the question number 33. Now we are on section D, question number 32, and it's given the question that one observer estimates the angle of elevation to the basket of a hot air balloon to be 60-degree, while another observer 100-meter away observes the 100-meter away estimates the angle of elevation to be 30-degree. So let's try to sketch the situation. Let's say this is the basket of the hot air balloon, and this is the ground where the observer is, and this is the height of the basket from the ground, and this is the angle of elevation of the first observer and the angle of elevation of the second observer, and the angle of elevation of the first observer is 60-degree, while the second observer, the first observer is at A and this is B, which is 30-degree. Or let's say AB is the height of the hot air balloon from the ground AB. C is the first observer and B is the second observer. And the distance between them is 100 meter. And now we have to find the height of the basket from the ground. So first of all, we have to find out AB, and B part says this is part A. And for B part, distance of the basket from the first observer's eye, which is AC. And then we have to find the horizontal distance of the second observer from the basket. Horizontal distance from the second observer from the basket is from the horizontal distance of the second observer from the basket, which is so this the horizontal distance of the second observer from the basket means we have to find out this distance from the basket horizontal distance, which is BD. So we have to find BD. Now let's find out AB, that is the height, and for that let's take this right angle triangle. So this right angle triangle ABC. If we use tan of 60, which will give us AB by BC, and tan 60 is the root 3. So this is AB, and BC. If we cross multiply this will give us AB is equal to BC in this, let's say, first equation. And now in the right angle triangle ABD, and this is tan 30, which is equal to AB by BD. Now tan 30 is 1 by root 3, and AB, we have the AB with, from the first equation, which is BC root 3, and BD can be split up into DC plus BC. And DC is 100, so this is 1 by root 3 is equal to BC root 3. Value of DC is 100 plus BC. If we cross multiply this will give us root 3 into BC root 3 is 3 BC, which is equal to 100 plus BC. Now 3 BC minus BC, this is 3 BC minus BC, which is equal to 100, which is 2 BC is equal to 100. Now BC is equal to 50. So BC is equal to 50 meter, and this is equal to 50 meter, but we have to find AB. So from 1 we can get AB, which is the height of the basket from the ground, which is BC is 50, so this is 50 root 3. So we have got AB, which is 50 root 3. Now let's find out AC. So AB is 50 root 3, and we have to find AC, so we can use the sine ratio. So in right angled triangle ABC, if we use sine 60, which is AB by BC, and sine 60 is root 3 by 2 AB. So AB is 50 root 3, BC is, so sorry, it's not AB by BC, sine is, it's AB by AC. So this is AC root 3 gets cancelled, and AC is equal to 100 meter. So the horizontal distance of the first observer from the distance of the basket from the first observer's eye is 100 meter. And let's find out the third one. So we have got the height of the basket from the ground, which is 50 root 3, and the horizontal distance of the basket from the first observer's eye, which is 100 meter. And now we have to find the horizontal distance of the second observer from the basket. So horizontal distance is this one, which is 100 plus 50. So horizontal distance of the distance of the second observer is 100 plus 50, which is equal to 150 meter. So 50 to 300 and 150 are the respective answers of the questions that were asked in the question. So this solves our question number 32. Let's move on to the next one. Okay, for question number 33, part A, and we are going to solve the second part as well. So part A, this is question number 33, and it's given that triangle ABC is drawn to circumscribe a circle of radius 4 centimeters, so that the segments BD and DC are of length 10 and 8. And we have to find the length of the sides AB and AC. So let's try to sketch this figure, which is, so there is a circle that triangle has to circumscribe a circle. Let's say this is the circle, and these are the sides of the given triangle, and this is A, B, and C. O is the center, and D is the point of contact of the tangent BP. This is 10 centimeter, this is 8 centimeters. So let's join O to C, O to A, and O to B. So first of all, we are going to join O to A, O to C, and O to B. Now, uh, so OD is perpendicular. OD is perpendicular to BC as radius is perpendicular to the tangent at the point of contact. Similarly, if we draw the respective radius from O to AC, let's say the point of contact is E and F. So similarly, let's join or draw OE perpendicular to AC and OF perpendicular to AB, and OE and AF are the radius. So the radius is given, it's 4 centimeters. So this is 4 centimeter. This is also 4 centimeter, and this is also 4 centimeter. So OD is equal to OE is equal to OF is equal to 4 centimeter. These mean the radii of same circle. Now it's given that the area of the triangle is 90 centimeters square, so we are going to use that. And for that, this is perpendicular, and now it's given that area of triangle ABC is equal to 90 centimeters square. And before that, if BD is equal to 10, then BF is equal to 10, 8, and this is also 8. So BD is equal to BF is equal to 10 centimeter, and DC is equal to AC is equal to 8 centimeter. Also, let AF is equal to AE is equal to X centimeter, and we are getting this result because of the theorem that tangents drawn from an external point to a circle are equal. Okay, so it's given that the area of triangle ABC is 90 centimeters square, and area of triangle ABC is because of the sum of the areas of triangle BOC plus area of triangle AOC plus area of triangle AOB is equal to 90. Now, area of triangle BOC is half into OD into BC, and this is half into OE into AC. This is half into OF into AB, which is equal to 90. And now we are going to put the respective values in these, and I'm going to, okay, now let's put in the respective values. So this is equal to 90, and half into OD is 4 BC. So BC is 18, 10 plus 8 is 18, plus half into OE is 4, and AC is, this is x, which is x plus 8. So this is x plus 8 plus half into OF. OF is 4 into AB. AB is x plus 10. So this is x plus 10 is equal to 90. So this is 2 twos are 4, 2 twos are 4, and this is 36 plus 2x plus 16 plus 2 twos are 4. This is 2x plus 20 is equal to 90. 2x plus 2x is 4x. This is 36, 16, and 26 plus 6 is 12. 3 plus 2 is 5. And 7, this is 72 is equal to 90. and 4x is equal to 90 minus 72, which is equal to 18. So x is equal to 18 by 4. And we have got the value of x, sorry, which is equal to, let's say 4 4s are 16, 25. So x is equal to 4.5. Now, let's see what was asked in the question. So it was asked in the question to find the lengths of AB and AC. So we have to find AB and AC. So AB was 10 plus x. So this is 10 plus x, and AC was x plus 8. So this is x plus 8, which is 10 plus x, which is 4.5, and this is equal to 14.5. This is 8 plus 4.5, which is equal to 12.5 something. So 14.5 and 12.5 are the respective lengths of AB and AC. And let's move on to the next part of the same question. And it's given that two circles with center O and O dash of radii 6 and 8 centimeter respectively intersect at 2 points. So this is for part B, and the figure is somewhat like for the two circles, and the center of the first circle is O, center of the second circle is O dash. They are joined, and this is the common chord which intersects the line joining the center of the two circles at A. Common chord is PQ. This is the tangent from the center O dash to the circle with center O, and this is the tangent from the other circle with center O to the circle with center O dash. Now, because this is the radius of this circle and this is the tangent, so this angle is 90 degree, and because radius is perpendicular to tangent at the point of contact, we have to find the length of the common tangent. So that is, we have to find the length of the PQ. Now, we know that the line joining the center of two circles is the perpendicular bisector of the common chord. And first of all, let's find out the OO dash. So angle OPO dash is equal to 90 degree, because OP is the radius and O dash P is the tangent, and we can write here that radius is perpendicular to the tangent at the point of contact. Now, the radii of, let's say this is the radii of the smaller circle with center O, and this is 8 centimeter. So in this right angled triangle, which is O dash P, we can use the Pythagoras theorem. So this is O dash square is equal to OB square plus O dash B square. Now O dash square, which is the hypotenuse, is equal to OP. OP is 6 square plus 8 square, which is equal to 36 plus 64, which is equal to 100. So O dash square is 100, and O dash is root of 100, which is equal to 10 centimeter. So the length of the line joining the two centers is 10 centimeter. Okay, now we know that we have done this in class 9, that line joining centers of two circles is perpendicular bisector of the common chord. So this is the perpendicular bisector. That means these angles are 90 degree, and we can say that PQ. Now I can write PQ as 2 times AP, as the line joining the centers of two circles is perpendicular bisector of the common chord. So PQ is equal to 2 times AP, and we are going to find AP so that we can get the length of the PQ. Now, how are we going to find AP? So let's use these two right angle triangles. The first one is in right angle triangle BOA. We can use the Pythagoras theorem and get AP squared. So AP squared can be written as O dash B square minus uh, OA. So this is not O dash, this AP square is equal to uh, it's OB square minus OA square. Now AB square, so OB is 6, so this is 6 square minus OA. So let's keep OA as OA square, which gives us AB square is equal to 36 minus OA square, and let's say this is the first set of equation 1. Similarly, in we can use in right angle the triangle. The next one is O dash O dash EA. We can use the Pythagoras theorem, which gives us AP square is equal to O dash B square minus O dash A. So AP square, now O dash B is 8, so this is A square minus an O dash A. So O dash A, I can write it as 10 minus OA. So this is 10 minus OA, the whole square is actually square. So let's open this and expand this 64. This is A square, my A minus B, the whole square, which is A plus A square plus B square minus 2 into A into B. So this is 20 into OA. And if we open this, which gives us AB square is equal to 64 minus 100 minus OA square plus 20 into OA. This is our second set of equation. Now from 1 and 2, this is 1 and this is 2. So we can say that from 1 and 2, it's 36 minus OA square is equal to 64 minus 100 minus OA square plus 20 OA, 20 into OA. Now negative O square gets cancelled. This is 36, so I can write it here. So this is 36 is equal to 64 minus 100 is negative 36. So this is negative 36 and plus 20 OA. So 36 plus 36, this is 20 into OA is equal to 72, and OA is equal to 72 by 20, which will give us 36, and this is 10. So this is equal to 3.6 centimeter is the length of OA. So, but we have to find the length AP. So let's use this 1. So I can write from 1. So 1 was the equation. This is AP square. So AP square is equal to 36 minus this is OA square. So OA square is 3.6 the whole square. So AP square is equal to 36 minus now 3.6 square is square of 36, which is equal to 1296, which will be 12. This is 12.96. So AP square is equal to this is 36 minus 12.96, which will give us 4. 0, and this is 4 and 2. So this is 24.04, which can be written as 2404 divided by 100. So AB is equal to square root of 2404 divided by 100. Now square root of 2404 is 04. So we can get the square root of 2404. Okay, this is 1064, and okay, this should be 3. And this is 23.04, and this is 2304. Now the square root of 2304, so 2304 divided by 100. So 2304 square root is 4, 4 are 16, 13 minus 6 is 7, 4 fours, and the square of double of 4 is 8. So this is 86 into 6, which will give us 36, and 8 6 are 48, and 3 is okay. We have to okay, we have to get 4. So this is 80. 8 are 64, 8 are 64, and 60 is 70. So this is 48. And the square root of 2304 is 48, and square root of 100 is 10. So this is 4.8. So AP is 4.8. So we have got the length of AP, and PQ is now 2 into 4.8, which is equal to 9.6 centimeter. So the length of the common chord is 9.6 centimeter. Let's move on to the next question. For question number 34, part A, it's given that a train travels at a certain average speed for a distance of 54 kilometer, and then for a distance of 63 kilometer, its average speed increases by 6 kilometer per hour more than the first speed, and for the total journey it takes 3 hours to complete. What was its first average speed? So this is question number 34, and let first average speed of train be x kilometer per hour. Now, uh, for the first case, the distance was 54 kilometer, and the speed is x kilometer per hour. So time taken is distance by speed. So this is distance by speed, which is 54 by x hours. Now, and for case 2, the distance was 63 kilometer per hour, and speed now is 6 kilometer per hour more, so which is x plus 6 kilometer per hour. And the time, let's say t2, is again distance by speed, which is equal to 63 upon x plus 6 hour. Okay, it says that if it takes 3 hours to total 3 hours to complete, so according to question, total time, that is t1 plus t2, is equal to 3 hours, and t1 is 54 upon x plus 63 upon x plus 6 is equal to 3. Let's try to get a quadratic equation out of these. So it's x into x plus 6, which is 54 into x plus 6 plus 63x is equal to 3. Now this is 54 into x plus 54 into 6, x 6 over 24, 30, 24 plus 63x, and this is equal to 3x squared plus 6x, which is 18x, which will give me the equation. This is 3x squared plus 18x, 54x plus 63. 4 plus 3 is 7, and 6 plus 5 is 11. So this is negative. If I shift this to the right hand side, this is negative 117x minus 324 is equal to 0, which gives me 3x squared plus 17 minus 8 is 9, 10 minus 1 is 9. So this is negative 99x minus 324 is equal to 0. And we can take 3 common, which gives us x squared minus 33x minus this is 3 1 the 3 8 are 24 is equal to 0. So let's try to solve this equation, which is x squared minus 33x minus 108 is equal to 0. And the factors of 108 are 254, 227, and this is 3, 9, and 3, 3. So this is 2 to the 4, 4, 3 to the 12 into 3 is 36, and 3. So x squared, this is minus 33x plus 3x minus 108 is equal to 0. This is 108. So this is x into x minus 36 plus 3 into x minus 36 is equal to 0. So x minus 36 is common. So this is x plus 3 is equal to 0, which gives us x is equal to 36 and x is equal to negative 3, which is not possible. So the average speed of the train is equal to 36 kilometer per hour. And let's move on to part B. So the first one is solved for the average speed of the train is 36 kilometer per hour. And let's move on to the next part. So for the next part B, it says that two pipes together can fill a tank in 15 by 8 bars. Okay, I'm going to erase this. Okay, for part B, it's given that two pipes, they can together fill a tank in 15 by 8 hours, and the pipe with larger diameter takes 2 hours less than the pipe with smaller diameter to fill the tank separately. And we have to find the time in which each pipe can fill the tank separately. So let's say the time taken by pipe of smaller diameter to fill tank separately will be x hours. And time taken by pipe of larger diameter to fill tank separately be, so it's not y hours, it's given that it takes 2 hours less, so that should be equal to, so this is now equal to x minus 2 hours. Now it's given that two pipes together can fill a tank in 15 by hours, so time taken by both pipes to fill the tank, which is given is 15 by 8 hours. So what would be the part of, so from this we can get that part of tank filled by the pipe of smaller diameter in 1 hour. So part of tank filled by smaller pipe in 1 hour will be 1 by x. And part of tank filled by pipe of larger diameter in 1 hour will be 1 upon x minus 10. And from this we can get the part of tank filled by both pipes in 1 hour, which will be 1 upon 15 by 8, and that will be 8 by 15. Now, this is the part of tank filled by small pipe in 1 hour, which is 1 by x, and this is the part of tank filled by the larger pipe in 1 hour, which is 1 upon x minus 10. So both of them can fill the part of the tank in 1 hour, which is equal to 8 by 15. So if I can add them, which gives me 8 by 15, and let me get the quadratic equation out of this, which will be x into x minus 10. So this is x minus 10 plus x is equal to 8 by 15. So x plus x is 2x minus 10 upon x squared minus 10x is equal to 8 by 15. So 15 to the is 30x minus 150 is equal to 8x squared minus x, which gives me 8x squared minus 80x minus 30x plus 150 is equal to 0. And this will give me the equation 8x squared minus this is 110x plus 15 is equal to 0. And if I take 2 common, which gives me 4x squared minus 55x plus this is 75 is equal to 0. And let's try to solve this quadratic equation. This is 8x squared. Okay, let me just check it once again. This was 1 plus x plus 1 upon x minus 10 plus 8 by 15. And if I take LCM, this is x minus 10 plus x, 2x minus 10, x squared minus 10x is equal to 8 by 15, 15 to by 30 minus 150, 8x squared minus 80x. So 8x squared minus 80x minus 30x plus 150, which gives me 110, and 4x squared minus 55 plus 75. We have taken some information incorrectly, and which is the 2 hours. So this is 2, and I have written it incorrectly. It should be 2. So this is 1 upon x minus 2, and let me get this quadratic equation again. Okay, so this is x minus 2 and x upon x minus 2, which gives me x minus 2 plus x is equal to 8 by 15. So x plus x is 2x minus 2. This is x squared minus 2x is equal to 8 by 15. This gives me 8x squared minus 16x is equal to 30x minus 30. So this is 8x squared minus 16x minus 30x plus 30 is equal to 0. And this is now 8x squared minus 46x plus 30 is equal to 0. If I take 2 common, this is 4x squared minus 23x plus 15 is equal to 0. 4x squared minus 23x plus 15 is equal to 0, and 4 into 15 is 60. So let's get the factors of 60. So it's 2 into 30 and 2 into 15, and 3 5s are 15. So it's 2 to the 4 to the 12 and 5 to the 15 into 2 is 30. So we have to get 4. It's 4x squared minus 23x plus 15. Okay, 15 into 4 is 60. So we have to get the factors of 60 such that their product is 60. And if we add or subtract them, that should give us 23. So the factors should be, it's 2 to the 4, 4 to the 12, and 5. So it's 2 to the 4, 5 to the 20, and 3. So this is, I can write it as 4x squared. This is 2 to the 4, 4, 5, that is 20, and 3. So the factors are 20 and 3. So this is 20x minus 3x plus 15 is equal to 0. And if I take 2 common here, so okay, 4x is common, which gives me x minus 5 minus 3 into x minus 5 is equal to 0. So x minus 5 is common, and which gives us 4 minus. So either x is equal to 5 or x is equal to 3 by 4. So so x is equal to 3 by 4 is not possible, as because this will give us x, if we use x is equal to 3 by 4. So this value is rejected. X is equal to 3 by 4. X cannot be equal to 3 by 4, because if we take the value x is equal to 3 by 4, which will be equal to 0 point something, and if we subtract this, because if we take x is equal to 3 by 4, then the time taken by the larger diameter, which is x minus 2. So if we put x is equal to 3 by 4 here, so 3 by 4 minus 2 is equal to 4, 3 minus 8, which is equal to negative, which is less than 0. So this value is rejected, because for x is equal to 3 by 4, x minus 2 is less than 0. So x cannot be 3 by 4. So for x is equal to 3 by 4, x minus 2 is less than 0. So our the value of x is 5. So that means that the time taken by the smaller tab is 5 hours, and time taken by the larger tab is 5 minus 2 is equal to 3 hours. So we can write smaller diameter tab. It fills the tank in 5 hours, and larger diameter tab, it fills in 5 minus 2 is equal to 3 hours. And also we have not taken this x, we have not considered x is equal to 3 by 4, because if we take x is equal to 3 by 4, that will give us the value of x minus 2 and less than 0, which is not possible. So we are not considering this. And the value of x is 5, which gives us the smaller diameter tab fills it in 5 hours, and large diameter tab fills it in 5 minus 2 is equal to 3 hours. Let's move on to the next question. For question number 35, it's given that a horse is tied to a peg in one corner of a square-shaped grass field. of side 15-meter by means of a 5-meter long rope. So this is question number 35. And let's get our square shaped grass field. So this is, let's say, the square shaped grass field. And now the horse is tied to peg at one corner. So peg is a small wooden piece that is pushed into the ground, and the rope is tied to it. So it's the horse. Let's say this is the horse. So it's tied to a 5-meter long rope. So this is 5-meter long rope, and this is the area where the horse can graze, and which is in the shape of a quadrant and which has angle 90 degree. So the length of the rope is 5 meters, so it can be extended to a maximum distance of 5 meter, and the square of the side of the square shaped grass field is 15 meter. So that means it's not going beyond this field. Now we have to find the area of that part of the field in which the horse can graze. So area of field in which horse can graze is in the form of a quadrant, which is sector with angle central angle 90 degrees. So it's theta by 360 into pi r square. So theta is 90 by 360 into pi is 22, which is 3.14 into 5 square. So this is 4, and this is now 3.14 into 25 by 4, and this is 6.25. So 3.14 into 6.25 will give us the value. So this is 314 into 625, which will give us 196250. So this is 196250, and it's 19.62. We can say 19.625 meters square is the area that horse can graze. So this is the area horse can graze. Okay, now moving to the next part of the question is we have to find the increase in grazing area if the length of the rope is increased by 10 centimeters. So increase in area when length of the rope is increased by 10 meters. So increase in area when length of rope is increased by 10 meter would be, now the length of the rope is increased by 10 meter. So this is now the length of the rope, which is 10 meter, and this is the increase in area, which is the sector with radius 10 meter minus the sector with radius 5 meter. So this is 90 by 360 into 3.14 into radius is now 10 squared minus this is 19.625, 19.625. So this is 4, and 3.14 into 10 into 10 by 4, which gives us, so this is 314, and 3.14 to 10 into 10 is 314 by 4 minus 19.625, and 314 when divided by 4. So 314 divided by 4. 314 divided by 4 gives us 78.5. So this is 78.5 minus 19.625. And if we minus 78.5 minus 19.625, which will give us 58.875 meters square. So this is Let's subtract it. So it's 78.5 minus 19.625. So this is 5, 7, 8, and it's 8, 5. So 58.875 meters square is the increase in the area when the length of the rope is increased by 10 meter. So this is 58.875 meters square is the increase in the grazing area when the length of the rope is increased by 10 meter. Let's move on to the section D. For question number 36, it's given that a golf ball is spherical in shape, has about 300 to 500 dimples that have increased its velocity while in play. And these are the dimples which are hemispherical in shape. And it's given that there are total of 315 dimples which are hemispherical in shape and has a radius of 2 mm. And the golf ball has a diameter of 4.2 centimeter. So this is question number 36. And it's given that the diameter of golf ball is equal to 4.2 centimeter, which is equal to 42 millimeter, and which gives us the radius of golf ball, which is equal to 41 millimeter, and radius of hemispherical dimple is equal to 2 millimeter. Now moving on to the first part, it says find the area of one such dimple. So surface area of one dimple is the surface area of the hemisphere, which is 2 pi r square. So this is into 22 by 7 into radius is 2 square. So this is 2 into 22 by 7 into 4, which is 44 into 4 by 7, and that is equal to 176 by 7 millimeter square. Now the next one is to find the volume of material dug out to make one such a dimple. And volume of material dug out to make one such dimple is the volume of the hemisphere, which is 2 by 3 radius is 2 cube. So this is 2 by 3 into 22 by 7 into 8, which is 44 into 8 by 21, and this is 352 by 21 millimeter cube. Okay, so next one, the third, we have to find the total surface area exposed to the surroundings. So total surface area exposed to the surroundings is equal to the total surface area of the ball, which is 4 pi radius is 21 square, plus the total surface, the surface area of the hemispherical dimples, which are 315 in number, 2 pi into 2 square, 2 pi r square, where 2 is the radius. But as we included the total surface area of the ball, it also included the top circular region of the hemisphere, which has to be included because these dimples are dug out. So we have to minus the top circular region of the 315 hemispherical dimples, which is the area of a circle of 315 hemispherical dimples. Now this is 4 pi into 21 square is 441. This is 315 into 8 pi minus 4 into 315 in 5, which gives us this is 4 ones are 4, 4 fours are 16, and 17645 plus this is 8 fives are 40, 12 8 these are 20, 24 and 25, 24520. This is the half of 2520, which is 1260, and this is 5 5 over 20 262, and this is now 17645 plus 2520 minus 1260 is 12605, and 1764 plus 120 is 4 plus 0 is 4, 6 plus 6 is 12, 7 to 9 and 1 10, and 30245, which is equal to 3024 into 42 by 7 is 7 4 the 28, 3 the 29, and 3 the 21, and 2 the 14. So this is equal to 432 into 22, 468 into 8, 64, 4, 10, 8, 6, 14, 15, and this is the total surface area exposed to the surroundings is 9504 millimeters square. Okay, now moving on to the B part, uh, we have to find the volume of the golf ball. So volume of golf ball, this is part B of third one, and to find the volume of golf ball, which is equal to the volume of the hemisphere, a sphere which is 4 by 3 pi r cube, and we have to subtract the volume of the hemispherical dimples because they are dug into the ball. So this is 315 into volume is 2 by 3 pi radius is 2 cube. Okay, so this is now 4 by 3 into 22 by 7 into 21 cube is 21 into 21 into 21 minus 315 into 2 by 3 into 22 by 7 into 2 cube is 8. So it's 3, 7 are 21, 7, 7 gets cancelled, 3, it's 3 on the 3, 105 gets cancelled with 7, 7, 1 are 7, and 7 5 is 35. So this is 4 into 22 is 88, and 21 into 21 is 441 minus. This is 15 into 222 is 44 into 8. Okay, so 88 into 441. So 441 into 88 is 8 1s are 8, 8 4s are 32. 32 and 3 is 35. So this is 3 5 2 8 8 2 10 5 2 6 7 8 8. So this is 3 8 8 0 8 minus. Now 15 into 8 is 8 5s are 40 and 120. So 12, let's multiply 44 with 12. So this is 88 into 44. So this is 8 8 4 12 5. And this is 5280 millimeter cube. So if we subtract 38808, so this is 8 2 5 3 and so this is 33528 millimeter cube, and this is 33528 millimeter cube is the volume of the golf ball. And this solves our case study 1, that is question number 36. Let's move on to the next one. For the case study 2, that is the question number 37, a middle school decided to run the following spinner game as a fundraiser on Christmas Carnival. This is the spinner 1, this is the spinner 2, and it's given that spin each spinner once, blue and red makes purple. So if one spinner shows red and the another blue, that makes purple and you win. So one such outcome is RB. We have to list all the possible outcomes of the game. So all the possible outcomes of the game are so possible outcomes of game are. So this is the first, let's say this is the first spinner which has red, green, and yellow regions. And then is the second spinner which has red, blue, and green regions. Now the possible outcomes are red, red, red and green, red and yellow. This is blue, red, blue, green, blue, yellow, and then green, red, green, green, and green with yellow. So these are the possible outcomes. We can write it as the possible outcomes of the game are, we can write it as red, 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 green, red, yellow, blue, red, blue, green, blue, yellow, green, red, green, green, and green, yellow. This is the sample space, and we have a total outcomes of nine. So total outcomes are nine. Now we have to find the probability of making purple. So purple is made when we have the red and the blue. So for the second one, the probability of making purple is the probability of R and B, red and blue. So sorry, blue and red. So spinners blue and red makes purple. So this is blue and red. Okay, RB blue red is one and the same thing. This is the probability of red and blue. Red and blue, which makes purple. So red and blue, we only have one option for red and blue. So that means the probability of making purple is 1 by 9. And for the third one, part A, it's given that a participant gets rupees 10 for winning and she has to pay rupees 5 to the school. And if 99 participants played, how much fund the school have collected? So spinner wins when it shows red and the blue. So the probability of winning is the probability of getting red and blue, which is making purple, which is 1 by 9. And total number of participants are 99. So total participants are 99. Now, if total participants are 99 and probability of winning is 1 by 9, so the can number of participants that must win out of 99 with the probability of 1 by 9. So the number of participants that must win will be the probability of winning multiplied by the number of participants, which is 11. So these participants win. Now the number of participants that lose the game, that lose the game will be 99 minus 11, which is 88. Now the funds collected by the school, these funds collected by a school. Now the funds will be collected by the school when the losing participants they have to give money to the school rupees 5, so 88 into 5. But for 11 winning participants they have to give rupees 10, so we will have to subtract. So this is the money is earned from the losing and the money is given to the winners. So the losers will give this amount of money to the school, which is a fund collected, but we have to subtract the winning amount from the collected amount. So 8 5s are is 40, 8 5s are 440 minus 110, which is 330 rupees. Okay, now for third part B, it's given that if same amount of rupees 5 have been decided for winning or losing the game, how much fund had been collected by the school? The number of participants still remains same. So the number of participants still remains same. That is, we have to make changes just here. So now the funds collected by school is equal to they have to, it's given that amount 5 has decided for winning or losing. So it's the same amount for winning and losing. So it's 88 minus 5 into 11 into 5, which is 440 minus 55. And this is equal to 10 minus 5 is 5. 13 minus 5 is 8. So this is 385 rupees will be the amount. And this solves our case study 2. Let's move on to the final one, the case study 3 of this question. For case study 3, and that is the final question of this set. In a pool at an aquarium, a dolphin jumps out of the water like this, traveling at a speed of 20 centimeter per second. So it's given that speed is equal to 20 centimeter per second, and height above water level after t seconds is given by this equation, which is h is equal to 20t minus 16t square. Based on the above, we have to find the zeros of the polynomial. So given polynomial is p of t is equal to 20t minus 16t square, and to find the zeros, let's equate it to zeros. So this is 20t minus 16t square is equal to 0. T is common, so this is 20 minus 16t is equal to 0. So either t is equal to 0 or 20 minus 16 t is equal to 0, which gives us minus 16 t is equal to minus 20. So t is equal to 20 by 16, which is 10 by 8, 5 by 4. So the two zeros are t is equal to 0 or t is equal to 5 by 4. Okay, now, which of the following types of grass represent p of t? So the two zeros are t is equal to 0, which is here, and t is equal to 5 by 4, which is here. So for the second part, the answer is A. Now moving on to the third, for part A, what would be the value of h at 3 is equal to 3 by 2? So value of h is given by the equation. So for third part A, we have to find out the value of h when time is equal to 3 by 2, and h is equal to 20t minus 16t square, which gives us 20 into 3 by 2 minus 16 into 3 by 2 the whole square, which is 10, 30 minus this is 16 into 9 by 4, and 30 minus 36 is equal to minus 6 centimeter. The minus means the distance below the water. So it means that after 3 by 2 seconds, dolphin has reached 6 meter below water. So we can write after the time 3 by 2 seconds, dolphin is negative signs means below the water 6 centimeter below the water. Now Next one is how much distance has a dolphin covered before hitting the water level again means it hits the water level here and then it hits the water level here. So what is this distance? What is this distance? This distance covered by the dolphin. So this is part B. Now the distance covered by the dolphin would be the speed at which the dolphin goes up in the air is this is 20 centimeter per second. So 20 centimeter per second. And the total time taken 5 by 4. So time is 5 by 4 seconds. And or rather, this means that distance covered in 1 second is 20 centimeters. So distance covered in 1 second is 20 centimeter. Now the total time taken is 5 by 4. We have to find the total distance covered in 5 by 4 seconds. So total distance covered in 5 by 4 seconds is equal to 20 into 5 by 4 centimeter, which would be 25 centimeter. Okay, and this solves this set of the question paper. Do like, share, and subscribe. Thank you for watching.